quietness. Okay, for number one, right? For number one, up to now we have already been introduced to the notion of recurrence relation, and by now you know that an expression like this is a recurrence relation. And then here is cited a result 1 from the notes. Not to worry, even though we have not covered the part of the notes to talk about result 1, I will do it on the spot, right here, right now. It's not hard. It is quite within reach. Okay. So if you are given a recurrence relation like this, right? It therefore means to say that your x2, okay, x1 is just x1, okay, x1 is just x1, and your x2 is simply ax1 plus b. Okay. What is your x3? Your x3 will be a of x2 plus b. Can you see? And then what is your x4? Your x4 is a of x3 again plus b. If you go on with this pattern of thinking, very soon you will realize that xn is equals to a to the power of n minus 1 x1 plus a n minus 2 b. What is going on behind? Is there something you can tell teacher? So what I've just done is I'm doing what we have been doing. We just manually iterated the x1, the x2, the x3, and up to the xn based on this recurrence relation. Right? Based on this recurrent relation, I have managed to iterate up the x1, x2, x3 until xn. And once you have done so, you realize that these terms behind, right? They form a GP. It is easier for you to see this GP in this direction, in this direction. Right, where the first term is b and the common ratio is a. Okay, Jianhui, how many terms are there? 10. It's not n. How many terms are there? Jianhui, once more. Yeah, n minus 1 terms. I was trying to catch your attention because you are distracting Chen Rui. Okay. So based on this, right? Based on this, I can now write down the expression for xn as a n minus 1 x1. Okay, applying the GP formula, I have the first term 1. Okay. I use the formula, the common ratio, number of terms minus 1 over the common ratio minus 1, and there we are. We have gotten that blue patch. Okay, the blue patch. Okay, from the blue patch, right? This question basically wants you to show that the pink patch shows up. Rati, where is the pink patch? You see the pink patch? You don't see it, but where is it? Where am I going to color? Where am I going to color? Yeah, this is a deep pink, not very nice. This is a thinner. Okay, right. From here, we are going to establish the belief. Remember, in solving the recurrence relation of this nature, for the 2 lessons, right? I tried to sell you the notion that you need to believe the solution is such and such. I highlighted to you that whenever the reconciliation is of this nature, the solution will look like this. I told you to just believe. I gave you some calculation to make you believe, but now we are going to formalize it. How we can obtain the purple circuit portion. Okay, to do this right, we just simply need to rewrite. Okay, are you ready to rewrite? If you do rewrite this entire expression, you will get 1 over a x1 plus b over a minus 1. Okay, what is inside this box? Okay, and then what is inside this box? If you can read my mind, let's see. If you can read my mind, I like to hear from the floor. Sean, what is supposed to be in the first box? If you can read my mind, what do you think is to be in the first box? If you can read my mind, what do you say? Right now, you think about it. Look at the arithmetic. It's just arithmetical. It is simply arithmetical. That if you will tidy up the terms a little bit, you will agree with me, the green color. It's just arithmetical. Sean, so if you do see what I'm trying to write here, can you tell me what I would write for the second box? Minus? Almost. Sean, it is actually this. Yeah, B is on top. John, you're right. Okay. And after rewriting, you find that it is what it is. What do you mean, You will find that after rewriting, this A is actually this thingy. And this B is actually this thingy. So hopefully with this, you're convinced of the belief that I tried to hard sell to you the last time. Okay. The blue color is something you can do it manually by just writing down x1, by writing down x2, by writing down x3, x4, and then xn, and apply the GP formula, you get this. And from the expression, to obtain the pink color, it is just about rewriting. Okay, it's about rewriting. Kieran, you want me to repeat? You're good? Jerry, you want me to repeat? You're good? Okay. That is actually question 1. So after a while, we find that actually recurrence relation, right, is very little theory, It all can be done from bare hands. That's very nice about this chapter. It can be done all from bare hands. If you know APGP enough, you can actually do chapter 5 quite readily. Okay, let's do a question 2. Colin, you have some issues? You're good? Okay. Alright, we are on to number 2. By the way, Tara, let me ask you, what is RR? It's not rest and relax, it's not, no. It's recurrence relation. RR out there in the world typically represents rest and relax. There's also a t-shirt that's just printed that way, rest and relax. And it's RR. But over here it's not, it's actually recurrence relation. Okay, John suggests, how do I go about showing this? This is the original recurrence relation. The question is saying that by this substitution, we can rewrite the yellow to become the blue. This is what the question is saying. The question is saying that in the rectangular box, if you use a yellow, you can rewrite the rectangular box as the blue patch. So let me draw you an arrow to help you see things better. What the question says is, the blue box through the yellow patch becomes the blue patch. Okay, how do we start off the ball rolling? John, you want to suggest? So to start the ball rolling, we will start off with this line, the given recurrence relation. Okay, and then based on this yellow patch, I will write down my xn as un plus k, and then what is my xn minus 1? It will be un minus 1 plus k. Ken? Are you lost? I've simply followed the yellow patch. I'm guided by the question. The yellow patch says do it, so I did it. And then I have now got this expression soon. John is showing up very soon. Again, John, back to you again. Now I want this. How to make it happen? John, the magician, will tell us how this will happen. Brilliant! John says, just put this further to as 0. It's clever. So, where k is equals to b over, is right. We are done. Alright, so this part about rewriting is lame. It's quite lame, right? It's quite lame. We just simply rewrite, and we want the k to be like this. So bear in mind, therefore, our xn therefore is going to be un plus k, which means our xn has to be un plus b over okay. So what is left to be done here is we just need to solve for un. Okay, now is Vishwa. Vishwa, how do you think we will do to find un? Joshua, please. Oh, not Joshua, Vishwa. You start with this line. And very quickly, Visual recognizes that this expression is simply the what? The GP. If a term is obtained by multiplying A to the term before, this is a GP, isn't it? It's not general practitioner, no. It's geometric progression. Right? And Visual recognizes that this is a GP. He therefore knows that UN is equals to what? A into U1 to the power agreed? Visual, do you agree? Right. Then the question mark is, what is U1? Okay, Visual, what is U1? How do I know? There. U1 is just x1 minus k, right? And we already know k. Simi. I have made a mistake, right? Okay. Thank you for pointing out. No, I have made a mistake. Right. Thank you. It should be a to the power n minus 1 u1. I was setting alertness. Thank you. Okay. The good thing is I need space. I can do this, no? Shit, equal sign error. So there's gonna be a to the power n minus 1. Okay. Thank you for this. Okay. So now how to finish up the question? To finish up the question, right? I can then rewrite this thing here. So therefore my xn is equals to a to the power n minus 1 x1 minus b over, and again the good thing is no good. I'll just erase this. Plus b over 1 minus a. So what I did was I simply replaced so this gives you another way of solving the same thing, you know. And you realize that we are toying around the different ways to solve the same equation. After a few rounds of toying around, you find that going by the belief is the best. Going by the belief is actually the best. And it is with the same idea that we did the second order, right? So by the belief is actually the best, because people have done all the hard work for you. You just read their hard work. You just read what they have sold for you, and then use their results to make your calculation simple. So in the long and short of things, I'm here to advocate something, no, that you just want to believe. Yes. This portion, is it? Is it this portion? This portion here. This one, is it? This portion is to build up the argument that the K is this. That's all. No, the question says so lah. But in this question, the question wants you to show, right? So you show that it can be done so, and K is really what the question says so. You know, belief is not always easy all the time, you know. Belief, it's not easy, right? Especially nowadays with a lot of scammers all around, right? Seriously, no. People will not believe the others so easily these days. Right. I was trying to share with my daughter some of the scamming schemes that people have out there in the world. No? So I was trying to describe to my daughter over a cup of tea. You know, she told me in return, Daddy, those scams method you told me are the basic ones. She told me, the basic ones. She knew about them when she was in primary 5. She told me, I was a bit taken aback, I thought I was trying to educate her about scams, tell her not to fall into those scams. But she told me those are basics. Okay, I'm sure. Therefore, I'm quite sure that our students here, you already are very well trained in know all these scams out there. You won't believe people so easily. You be very cautious. Yeah, it's good to be cautious. Okay. Give yourself that 3 minutes to achieve this. Give yourself that 3 minutes to achieve this. But I'll go around to distribute what you've been waiting for. Anyway, you know your results already. There's nothing to be anxious about. The achievement's already done. Give yourself that 2 minutes to achieve. I'm sure I'll go around. Not there. Ooh. Let's see. Okay, we'll stop here. Stop. I like the last solution. It's very good. Short and sweet. There's nothing to be anxious about because you already know the results. James, again, well done. I know you're anxious to know what went wrong with your one mark, right? I'm sure India is also anxious to know where she lost that one mark. I know she said this teacher is not very nice. Okay, short this is performance because some GTs with 50. case I've done wrongly, let me know. In case I've done wrongly, done the scoring wrongly. This guy is going more. Acquisition, Chunri. This guy is good. What happened to Chunri? MC today? What's wrong with him? Do you happen to know? Did I tell you that my own classmate, was at the university, my own classmate passed away at the university. There's another classmate of mine who passed away when your age, after A lessons, my classmate. So I attended his funeral. So far, my own peers, 4 have passed away. One passed away about a month ago. Yeah. I was surprised. We were talking about going to Malaysia some more together, and it never happened. They just. Okay, I am very sure you love question 3. I am very sure you know how to do it. Because you did this in calculus, remember? We have done this in calculus millions of times. Did we not? To do by parts, right? By parts, you must decide one term to be differentiated and one term to be integrated. So the obvious choice in this case is to differentiate the x power of n and to integrate the e power of x. Okay, integrating e power of x is just e power of x. And then you differentiate the x power of n e power of x. Putting x as 1, you get e minus n I of, you are done. And then, do you remember how to find I5 from here? To find I5, this becomes E minus 5 I4 we did the last time, remember? And then this gives you E minus 4 I3. And this gives you minus 4e plus 20i3. And then right, this gives you e minus 20 I2. Then it gives you 16e minus 400 I2. And then this gives you 16e minus 400 e minus 2i1 minus 384e plus 800i1. Okay, and then same thing, no? Minus 384 e plus 800. This is going to be e minus I0. So this gives you 416e minus 800 I0, right? You get e power of x 0 to 1, you therefore in the end get 800 minus 384 E. I hope my calculation, my arithmetic is right now. I made a mistake, right? Oh. Okay, my bad. Should be 3. No wonder. I thought that the number is too big. I was testing alertness. Okay, 16E is correct. This is minus 60. Okay, so this gives you 60, 120. Okay, this is devastating, you know. Minus 44. Luckily, it can be erased so easily, you know. I1. Okay. Jianhui, do you have any mistakes? Let's erase the formula. Okay, so let's press on this minus 44 E plus 120 E minus 120 E to the power of X 0 and 1. I think it's correct here. Is minus 44 E plus 120. Okay. Right, so you have to know that this is also a kind of recurrence relation, you know. And then, as you would have suspected, I've named this file question 1, 2, and 3, and question 8. We did 5, 6, 7. Remember, we did 4, 5, 6, 7 already. Today we have done 1, 2, and 3. So join up with 4, 5, 6, 7. So the next question number is 8. Okay, so I can do number 8. Change it, you got something erased. This answer should be correct. Right, this one's okay. John? Yes. So number 3 is actually the good old days. What you used to do in calculus, right? Say again. This one is it? No, I didn't integrate. No, I've simply rewritten this fella. I've rewritten this fella as this fella. That's all I did. I didn't integrate. To create that recurrence relation, John, I was simply trying to create the recurrence relation here. Okay. So after establishing the recurrence relation, I use that recurrence relation to solve I5 by going through the usual way we did before. Okay, any question to raise for number 3? Okay, don't have, I can see you're okay. Let's do number 8. Okay, class, let number 8. Sure. Okay, let's start off with number 8. You are given a recurrence relation like this. Class, I want to tell you about this thing called the auxiliary equation. Auxiliary equation. How do you obtain the so-called auxiliary equation? Given a recurrence relation, you flush everything to the left. You flush everything to the left. And then your auxiliary equation is obtained like this, no? Okay, this could be new to you, no? This could be new to you, but we did one question before, wherein we so-called solve the auxiliary equation first. I'm not sure if you can recall. Do you remember? Okay, we didn't. We did in number 9, question number 9, remember? In question number 9, we did. Okay, we did. So in question number 9, we have already had a notion of this thing called the auxiliary equation, and now we are rolling back, to question 8. So in case I've forgotten, this is so-called the auxiliary equation. So if we say that this auxiliary equation has a repeated root, that means to say the roots are alpha and which also means to say alpha plus alpha is actually A, and number 2, alpha times alpha is B. Okay, so this is what we know from the start. Okay, this is what we know from the start, right? That A is 2 alpha and B is alpha squared. So the question wants you to verify 2 things. It wants you to verify that this is a solution. Okay, so how do you verify that this is a solution? We want to then start off this way, no? Substitute. Substitute x n as alpha to the power n into RR. Okay? To prove that something is a solution of an equation, right? The best thing to do is just plug it in, Okay. So for me, I'm going to plug in into the right hand side. Usually when we want to prove something, right, we want to start off with a more complicated expression. So I'm going to put in the left hand side now. I'm going to put left hand side and say this equals to okay, because it's not left hand side, I start right hand side. Okay, I start right hand side. And to verify that it is a solution, I must eventually show that this thing is going to be equals to alpha to the power n, which is your xn. Okay, class, I'd like to invite you to just use the number 1 and 2, number 1 and number 2 to just plug it in. Try. You just plug it in and see is it true or not. You put in your A as 2 alpha and put in your B as alpha squared, and you can very quickly verify that indeed it is alpha to the power of n. Jianhui, are you having some suspicion? I see the way you are looking at it now. So class, I'd like to invite you to put in number 1 and number 2 into the left hand side, sorry, the right hand side, put into A and B and show that it is indeed alpha to the power of n very quickly. You sure? Right, you're right. You're right. Change it is correct. There's a minus here, no? Do you see? There's a minus here. You're right. And then it works. Okay? Yeah. There should be a minus there in number 2 that Change pointed out. That's alert. I'm very happy. Okay, and then you plug it in. Yes, now it works. Okay, now that you have proven that this is true, you now want to show that it's so true for this. Oops. You want to also show that it's true for this as well. Go through the same motion. Start with the right hand side and show that in the end you get alpha to the power of n. You know what I'm saying? To prove the second one, to prove the blue patch, right? You will start off by putting xn as n alpha to the power of n onto the right hand side and show that in the end it acts out to become alpha to the power of n, and then you're done. Okay, what I meant is now you sub into the right hand side again. And again, you do the same thing, and you must show that eventually it is equals to alpha to the power of n, which is your xn, and therefore your left hand side. You just need to show this. So I leave it to you to do the green color because the time has come for us to end the lesson so that you can go for your PE. It's PE, right? Okay. The next time that I come in, right, we are left only about 3 more tutorial questions. Then we can roll back to the notes. And then we should be ending the syllabus in good time. I want you to know that the exam is next Friday, you know.